7.2 properties of exponential functions. So we talked about graphing in 7.1. Now we're going to actually get into the transformations of a graph. Now I'm looking at these two. Here's my parent function. Remember, the parent function can always change. You should always box in whatever number is raised to the x power. That's your parent function. Anything that is besides this box of your parent function, that's a transformation. So if we compare just these two, this number right here, this is like our A value when we're talking about transformations. They're all similar to other transformation questions that we've had in the past. So when we've done quadratics, absolute values, radicals, radicals, all that fun stuff, we still have the same transformations. We have a stretch, we have compress, we have reflect over x-axis, we have left, right, we have up, down. It's still true for here. So this is like my stretch. So notice how as I have a stretch, these numbers. So if you get back into our families, so here again, you should always box in your base, the base right here. Your A value, it's either going to be a stretch, a compress, or reflection. So if it's greater than 1, if this number right here is greater than 1, it would be a stretch. If it's less than 1, it's going to be a shrink. Remember, this is an absolute value because if it is negative, that will be a flip. You can call it flip. I will allow you to do that. This right here with the number with the x right here, this will move it left and right. Remember, this is always opposite. So if this says minus, it's actually going to be moving to the right. I'm going to be talking about the point. And then we also have this up or down, the k value. So these are the same transformations we've been dealing with for the last year: left, right, up, down, stretch, compress, flip. So when I'm doing this, first thing I notice is that this right here is my parent function. In my parent function, I see that this is going to be a growth because this is greater than 1. I can plug in both my parent function, so 3 raised to the x power, and I'm also going to plug in my negative 1 divided by 3 times 3 raised to the x power. Before I actually even get into graphing this, I can see that this right here, because this is negative, this is my A, that's negative, this will be a reflect, or else you can say flip over the x-axis. And this right here is going to be a compress because the 1/3 is smaller. Now when I'm graphing, when I go to my table, this is my parent function and this is my actual transformation. So if I go to my table, right here, I'm looking at these numbers right here. So I'm going to plot this number, 1, -1. Actually, before we get into that, we're going to talk about the point. The point is always whatever makes this 0. So if there's no adding subtracting here, the number makes 0. Typically in the parent function, it will always be 0, 1. The parent function, the point in which I'm looking at, will always be 0, 1. In this case, since I did not move left or right at all, my point here will be 0, -1/3. Okay, that's the point in which I'm looking at. So 0, -1/3. I'm also going to ask you for your horizontal asymptote. We talked about this in class, talked about this in 7.1, but your horizontal asymptote would be your k value. There's no k value. In this case, it's going to be at 0, meaning that there's that invisible line right here that will never actually pass. So right here, I'm going to put my dotted line. It has to be dotted, so that's my horizontal asymptote. So the shape here is going to be growth. We already talked about that. That will be my shape. So now if I plot these points, I would have a shape that looks like this. Again, because of that negative out in front, it flipped. Because of this 1/3, it actually compressed. And if we push graph, this is what our parent function looks like. Woo! The blue one and the red one is our transformation function. Now we're also going to talk about the domain. The range. When I look at this, remember range is your y value. So when I'm looking at this value, how far down do I go? I'm going down forever. How far up do I go? I stop. This horizontal asymptote, it's blocking my way. It will never pass this line. So in this case, because the graph is below this line, y is going to be less than. It's not or equal to because it's never going to touch this. It will never touch that. So then y is less than 0. Right now, I want you to graph this, and I want you to try to find these 4 things also from this graph. So this graph is very similar. The difference is because of the compress, it's a little bit larger, and my parent function is a larger base. My 5 is a larger base, but the actual shape is going to be growth. I forgot to write that. So now again, when I'm looking at my range right here, it is below my asymptote, so it'd be less than, and then my horizontal asymptote is at 0. So now if I look at my next one, I have a lot more transformations here. So the first thing I'm going to do is box in my parent function. 2 to the x is my parent function. So right here, if I'm going to state the transformation, this is with my x value. X moves left and right. Remember, x value is always opposite. So this is going to move to the right 4. This right here moves up and down. This will move up 3. So when I'm looking at my information here, I'm going to put shape and range. Those are the 3 things I want you to pay attention to. Now my point will always move because typically this is 0 at 0, but in this case, this will not make it 0. If I plug 0 in, I'm not going to get 0. So if whatever the transformation is left or right, that's where I want to look for my point. Okay, so I'm going, a positive 4, because it moves to the right 4. So I'm going to look for a positive 4 into my graph. So if I go to my graphing calculator, and then I go to my table, I'm going to go to negative or positive 4. And this right here will be my point. This is kind of the point. Now when I'm talking about this point, this is where the point where it starts moving to the up and down, the growth, or decay and up on the other side. So it kind of is that point where the two kind of split off. So I'm going to plot these points. Now, if for some reason you're like, I don't know where the horizontal asymptote is, this will be a key indicator. This will help you. Look at, it's getting so close to 3, but never ever moving past it. So this up 3, that moves my horizontal asymptote. So my dotted line that I need to have on my graph would be my horizontal asymptote at 3. If you ever try to graph it, you should also be able to see where this is getting super close to, but never actually passing. It looks like it's passing 3 right there, but it's just because the graph gets so close to that, it looks like it, but it's never actually passing. When you are graphing this, you have to make sure you have arrows at both ends of the graph. So my horizontal asymptote here, I went up 3. My shape, my 2, that is a growth. It's exponential growth. Again, now I'm looking at my range. So my range is how far down do I go to how far up. Now, when I'm looking at this, this is a limitation. This is like for dogs, your invisible fencing. So it can never cross that. So this is at y is 3. When I look at this graph, it is above it. So y is greater than 3. It's not or equal to. So I want you to try to do B by yourself. So I'm moving a stretch of 4 and moving down 2. My parent function is a decay. So my point, if I plug 0 into this equation, because I didn't move left and right, so that's why I'm choosing 0, my point would be 0, 2. So at 0, 2, this is kind of where it starts going down and starts going up. So again, at 4, 4, that's where it was kind of like going down and then changing to going up. When I'm looking at this, my range, my graph is above my asymptote. So it would be greater than, because the graph is above this, and it will never touch at negative 2. These next set of questions is asking just for the transformation. So first thing you should do is box in your parent function. The only thing that's different besides my parent function, because this is not part of the parent or the transformation, is this plus 2. So this will move the opposite. So this will move left 2. That's my answer. So again, I'm going to box in my parent function. So I want you to pause the video to see if you can state this transformation. The 5 here will stretch it, stretch a 5, and this will actually move it up 5. So I have 2 transformations. Again, do not include the parent function. So far we have done parent or my base functions is when we have rational numbers, meaning that the decimal stops or it's a whole number. We will get into irrational bases. One important irrational base is e. We'll talk about when we have e to the x power. E is another irrational number, just like pi is irrational. E goes on forever, never repeats, and it's a number that typically is used in business when we're continuously compounding money. A lot of times on Wall Street and finances that you're getting money every single day. You're getting money, you're giving money every day. And there you have it. Bing, bada, boom. Have a great day.